In this section, we're going to be looking at the series underbar FIR command. FIR refers to finite impulse response time. It is typically used in digital signal processing, such as that used in commercial or amateur radio. Now, when we say finite, what we mean is that we're going to have an array of values, and that continued over time, we expect the values in that array would eventually dwindle down until they're zeros. FIR analysis is a very specialized discipline that, to be honest, you probably won't need to use all that often. However, we can use this series FIR to help us mere mortals with some common processing needs. One that is quite common is to get moving averages. Here in this next example, I want to show a moving average of my last 5 values. What I'm going to do is use the range command to set up a series of dates for the last 24 hours in 1-hour increments. I'm then going to use summarize to create a list from that range of dates. Next up, I have project, and I'm just creating a dynamic array of values. And I'm also going to tack on my range of values from my make list T to the end. So I now have a data set that consists of this dynamic array of values and the date. Next, I'm going to actually implement my series FIR. Now, the first time I call it, you see I'm using series FIR. I'm passing in my val, which is that dynamic array. And the second parameter says dynamic, and it has 1, 1, 1, 1, 1. Well, what this tells us is, first off, I want to get the average of 5 things, because I have 5 ones out there. Then, what it's going to do is it's going to take the first value it finds, the number 10, and it's going to put it into that last spot. So the first 4 ones are going to hold zeros because there's nothing there. The last one is going to hold the value 10. Let me execute this query, and I think it'll make it a little more obvious what we're doing. So now we can see on the very first row, when our value is 10, it is placed 0, 0, 0, 0, and then the number 10. It then takes that, divides by 5, to give us our 5-hour moving average of the number 2. Now on the next row of our query, I'm calling this centered, 5-hour moving average centered. You can see the slight difference between this and the previous series FIR call. I have true as the third parameter and for the fourth. True in the third parameter means normalize this data. We don't want to use that if there's negative values, but if all of my values are in the dynamic or positive, in other words, all 5 ones are positive, we would put true here. The last true says make this centered. So what's going to happen is 10 is our first value. It's going to go where the middle number 1 is. It's then going to put the value 20 in the 4th slot and the value 30 in the 5th slot. And because there's nothing before 10, the first and second slots are going to be 0. Well, 10 plus 20 plus 30 is 60. 60 divided by 5 is 12. When we move to the next row, the 20 will now be in the last position for the first series FIR command. So we'll have 0, 0, 0, 10, 20. That gives us a total of 30 divided by 5 is 6. Then on our moving average, everything shifts over. We have 0 plus 10 plus 20 plus 30 plus 40, which gives us a value of 100. 100 divided by 5 is 20, which is what goes into our 5-hour moving average centered column. This will then be taken and put into MV expand, which is going to take all of this and expand it out to individual rows. Another way we can use series FIR is to show the difference between current and previous values. Here I have another query, and in this case, you'll note that my dynamic array that I'm passing into series fir has a 1 and a -1. I'm passing in false for normal and for centered. So let's visualize what's going to happen here. On the first row, my value is going to be 1. It's going to say, show me the difference between 1 and the value before it. Well, there is no value before it. On the second row, my value is 2. So the 2 is what drops into that first slot in the dynamic. Then the -1 says go back 1 position, so it's going to grab the number 1. 2 minus 1 is 1, and that's what goes into my diff column. We then repeat this. The next row is the number 4. 4 minus the previous value is 2, so 2 is what goes into the diff column, and so forth. This is very similar to using the prev command that you saw earlier in this course. However, it can be a lot more efficient when you're working with a dynamic series or array of data as opposed to looking at one row versus the previous row. Now let's do something a little more useful. I'm going to come down here and I'm going to have a couple of calculations. So I've got one called let filter out big values. When I do my initial calculation in a minute, the calculated value for the first row is going to be huge because there's no value before it. So I'm using this to filter those out. I then got something that says convert to minutes, where it's going to take a value that comes in nanoseconds and converts it to minutes. The round statement says, I want you to take that number and round it off to 2 decimal places. We then do the same thing to convert minutes into hours. Finally, we get down in here to our query. I'm going to run this a little bit at a time so you can see what's going on. So I'm going to highlight the pieces that I want to run. Let's come here and run this part first. What I'm getting is a listing of high CPU alerts for Contoso Retail's computer over time. I'm then going to summarize this by converting those times into a list. The other thing I am doing is taking those times and converting them to a long value by using toLong. Under the hood, all times are typically stored as long integers. What we're going to be able to do is take this time, convert it to a long, and then later we'll be able to do calculations off of this. After getting all of my times as longs within an array, I can run my series fir. What this is going to do is it's going to create a second array in the diff column, and you can see it has the difference in those long values from the current row versus the row behind it. I can then use mvexpand to convert this back into rows. Okay, that's good. But now what I'd like to do is convert these longs back into dates. So the time generated, I can simply use toDateTime. And now I've got that long value converted back into a time. I can then do my difference in minutes by passing in diff, and I can see the difference in actual minutes between that row and the next based upon the output of series fir. I can also take those minutes and convert them to hours so that I have a value that's a little easier to work with. I think you would agree that 47 hours is a little easier to understand than 2,829 minutes. I'm then going to go into my extend, and I'm going to filter out the really large values. You can see here in the output, I filtered away that first row with that extraordinarily large and meaningless difference in minutes and hours. Finally, I'm going to restrict this to just the columns I want, getting rid of those other columns. I did leave the diff in here just so that you could see it, but now that I have just the data I want, computer, diff, time generated, difference in minutes, and difference hours. I've got something really useful that I can actually employ on a daily basis thanks to the ability for series fir to quickly do these calculations.